Just go. All right. Hey, welcome back, class. So this is week 2 of online learning. If you haven't watched the first video, kind of walking through what we're doing this week, please go watch that first so you have an idea on what this week's going to look like, the different assignments and activities and things that we're going to be doing. So for this, we're going to walk through a quick demo, but also some intro on single replacement. So we're starting chemical reactions this week. New content, we wrapped up naming. And now that we can name these and that we know the charges and different things, we can actually start looking at reactions, which would be a lot more fun if you were here, because then we could actually go through these and have some fun labs. But you're at home, so you'll have to suffice with video for now. So kind of looking at the board here, single replacement reactions. Right here, we have our reactants. The first part of every chemical reaction on the left side of the arrow is going to be the reactants. And then this will be the products on this side, which we will write eventually. But as you can tell, it's single replacement, which means only one thing is being replaced. So you're always starting with two different things, but notice how this one, like here, for example, copper chloride here, has two elements, and then there's just copper here. So we're talking about one thing replacing the other. So another thing you're going to want to have out alongside you is this sheet, the toolbox. So the main thing is on this side, you have the activity series here. That is what we're going to use a lot, and we're going to need that throughout this time, because we can actually predict and write what's going to happen, what's going to replace what. So aluminum, and then with copper 2 chloride here is going to be the first one we're going to look at, and it's going to be this reaction. So here's our copper 2 chloride. Here's our aluminum. So keep in mind, think of the things, how do you know if it's a chemical reaction or not? You have a few different things you could think about, looking for color changes, bubbles, heat. Here, you can feel it. Did it feel hot?
One's broke.
It felt hot to me. So clearly you can see it's reacting. Okay, so we know that this reaction works, but when you're looking at this, how do you know what was actually made? So this is when we come back to the board here. So the first thing we're going to want to do is, just like ionic, we're going to want to know what our charges are. So this aluminum, which is a transition metal, but it's on your sheet on here. Aluminum is going to have a +3 charge. This is copper 2, so we didn't talk about transition metals, so you're not going to be expected to know that for a quiz or something like that. Because since it's copper 2, it's going to have a +2 charge. Remember, chlorine has a -1 charge. So we saw that it reacts, so we know that this aluminum is going to replace the copper. So now, the aluminum will not replace the chlorine, because then you have aluminum and copper together, two metals, two cations. That won't work. That's not what we saw there. That's not what's going to happen. So you simply will take this aluminum and you will replace it with chlorine, and then the single metal over here is going to be the copper. So that's going to be your first step. Second step is you're going to want to make sure things are balanced. So you know aluminum's +3, you know chlorine's -1. So if you do the crisscross, you're going to have 1 aluminum because it's +3, and you're going to have 3 chlorines because this is -1 +3, because then this overall charge of the anion is going to be -3, and it'll balance with that aluminum. So those are our products. This is what the reaction is yielding. You're going to see that language in your ChemQuest, which you'll do after this as you walk through. So that's our first single replacement reaction. Second one here is we're taking the copper chloride solution and we're mixing copper with it. So let's take a look at this one. So as we're waiting for this to settle, notice you don't see any bubbling like before, even if you compare. This one's still bubbling. If you feel this one, the phone felt it, hopefully sent to you. There's no heat, okay, and it's not cold either. So, and you can kind of see the copper on the bottom looks pretty much the same. So nothing really changed. So now this reaction, nothing happened. So what we're going to put on this side is we're going to put NR, no reaction. So this is where your activity series will come into play. So for example, copper and copper, they're the same thing, but whatever is highest on that sheet, on the activity series, is more reactive. So something lower, like for example, if we look at sodium, all in just this first box, sodium will never replace lithium. Lithium's higher on the sheet, it's more reactive. Whatever is more reactive is going to replace that what is not reactive. And since copper and copper are the same, this copper is not more reactive than that copper, so therefore it's not going to replace it. Just nothing's going to happen. It's going to be a no reaction. So we're going to have more examples of those on your ChemQuest. Third one, copper chloride, and now we're doing zinc. So here's our zinc, here's our copper chloride again. What do we see? Notice how it's darker. Looks slightly different. A little bit of heat, so you can feel some warmth. This one's reacting slower, but it's still going to react, and you can also look to predict, once again, knowing your activity series. So if you find copper and you find zinc on here, so zinc's going to be right here. Copper's way down here. Okay, so zinc is more reactive. So zinc is going to replace the copper. And we'll look at this again. There's an example of that one that's already kind of been sitting for a few weeks. So we'll look at that later. But so this is going to replace, it's going to react. So let's replace it. So you can start, the zinc's going to replace the copper, so zinc chloride. And then you are just going to have copper up here. But the charge on zinc is, if you look at, oh, that's not going to be up there. If you look at the bottom, kind of the known transition metals, zinc is going to be +2. And we know chlorine's -1. So we're going to have 2 chlorines to balance the +2 charge in the zinc. So if you're still struggling with that and you can't just write it down like that, write them out individually as ions. Write out their charges, circle them, crisscross them. Keep going through those steps until this kind of becomes second nature at this point. So that's our third reaction. Now we're going to move on to our fourth one. Right here, we're having magnesium and copper chloride. So here's our magnesium. Now we're going to pour copper chloride in this. So we're going to move closer to the sink because you never know what's going to happen. So if you look at this, you can see a lot of bubbles. It's getting warm pretty quickly. It's reacting a lot. So clearly this is a reaction. So we know this one's gonna work. So we're gonna set this back down in here. You can see them hopping around. It kind of looks like bubble tea in a way. Okay, so that's magnesium. So clearly that one works, and now you're not always going to be able to test all these on your ChemQuest if they're going to work. So that's why the activity series, we're going to keep going back to the activity series. If you lost this sheet, it is linked on this week's page. So magnesium +2 charge, okay. You know that from the periodic table. Remember, it's in group 2, 2 valence electrons. It's losing 2, +2 charge. It's going to replace the copper. We know chlorine's -1. So magnesium, chlorine, you're going to need 2 of these to balance the +2. And then once again, copper out here by itself. So now for metals, typically things get more reactive as you move down the periodic table. So if you think back to a demo we did in group 1, we threw lithium in water, and then we did sodium. Lithium kind of caught on fire and it scooted around on the water, but didn't really do a whole lot. And the sodium exploded. We didn't get to potassium, but as you move down the group, you saw it became more reactive. And you're going to see that on the activity series, and then also that same trend works. So if you have magnesium, okay, which we just did and it reacted decently well, now we're going to go to calcium. Okay, so we're going to have something that's more reactive, so you can kind of predict what's going to happen. So here's our calcium. Kind of looks like rocks. Now we're going to add this. can see already how it's building. Starting to get warm. I'm gonna set it down. Move it closer to the sink. So that one's reacting a lot more than the magnesium was. Even to the point to where it's starting to bubble over and is going to make a mess. You can still see the magnesium over here still reacting as well. So, obviously that one reacts. So now to write out this equation, it's going to be the same thing. So, calcium chloride plus copper calcium. Find your periodic table, find the charge. Where is calcium? Is that in the first group?
Second.
Second group. My glasses are not working wonderfully. So calcium is going to be a +2 charge. Chlorine we know is a -1, so once again it's going to be 2 chlorines to balance that. So single replacement reactions. Pretty simple. Just one thing replacing another. That's all we're focusing on this week. Next week we'll get into double replacement. Bit trickier, but not too bad. Then we'll look at some other reactions, also like combustion, different things like that. And we'll also balance these. So as you noticed, some of these things, like there's 2 chlorines on this side, there's 3 on this side. So we know that matter wasn't lost, it didn't get destroyed, right? The conservation of matter, one of the laws we know. So we will balance these later, but we're not gonna focus on that this week. Okay, so if you are freaking out about that, like why isn't this balanced? Why isn't it the same? We will get to that later, just not right now when we have more time. So looking over here now, we can see kind of what these look like. I'm not gonna move that one. So these are in the relative same order. Now, this one over here is this one, so it is slightly different. But you can see the difference over time. So the one that didn't look like it reacted a lot right here, the third reaction we did, after a while, we can clearly see a difference. And our calcium's still fizzing. But anyway, so that's single replacement reactions. You're gonna do a ChemQuest next on that and be walking through that. And after you submit that, the answers will be open for that. But you need to use this sheet, okay? You're gonna need to use the activity series here. If you don't have that out, you're not gonna be able to do it well. So walk through that, take it step by step. If you want a video call with 2-3 friends and share it out and do it as a group, that's fine. Just make sure you each submit your own copy at the end. So after you finish the ChemQuest with some friends, make a copy of the finished one and each submit it, so I can give you points for that. Anyways, that's all I have. Hope you're having a wonderful quarantine in your house, as we are here in the school. So I'll see you later.